Hey guys, it's Miss Ewing here with another learning video. The title of this video is Adding and Subtracting Fractions. This is something that we definitely need to focus on because there are some very specific rules we need to follow. Let's take a look at a few fractions. If I have 1/4 plus 2/4, that's a pretty easy problem. Since the denominators are already the same, at fourths, we can just add the numerators. 1 plus 2 equals 3. Pretty simple. Let's look at another one. Let's say I have 2/5 plus 1/5. Again, our denominators are the same, so we keep that, and we just add the numerators. 2 plus 1 equals 3/5. But what happens if our denominators are different? Let's say my problem was 1/4 plus 1/3. If you think about this in terms of cakes, one cake is cut one way, and our second cake is cut in a completely different way. Those pieces are not similar at all. So the first thing we need to do is somehow make them more similar. We do that by finding a common denominator. An easy way to find a common denominator is to find the least common multiple. So let's start by listing our multiples of 4. 4, 8, 12, 16, and 20. And then our multiples of 3, 3, 6, 9, 12, and 15. Sometimes you have to go much further than that, but it looks like we found a match. Our least common multiple is going to be 12. So what does that mean for our problem? Let's make a little bit of room here. I can't just change denominators without changing the whole problem. So the process, we're trying to get here, and I have to ask myself, what times 4 gives me 12? Well, I know that 3 times 4 will give me 12. Whatever I do to a fraction on the bottom or in the denominator, I also have to do in the numerator. 3 times 1 gives me a 3. And then I go to the second portion. What number times 3 gives me a 12? Well, that would be a 4. Remember, what I do on the bottom, I have to do to the top. 1 times 4 is 4. Now that my denominators are the same, I'm looking at the same portion or the same cuts of a piece of cake. I go ahead and keep my denominator and simply add my numerators. 3 plus 4 is 7. Always ask yourself, can I reduce this fraction? Since 7 is a prime number, in this case I cannot. Let's take a look at one more. Let's say this time I have 1/2 plus 1/5. Again, two pieces of cake that are not very similar. So let's find our factors of 2. Our multiples of 2. 2, 4, 6, 8, 10, and then our multiples of 5. 5, 10, 15. Looks like we already have a match. 10 is going to be our least common multiple. So my goal is to get both denominators at a 10, and I ask myself, what number times 2 gives me 10? That would be a 5. Whatever I do to the denominator, I must do to the numerator. 5 times 1 is 5. And similar to the other side, 5 times what number gives me a 10? Well, that would be 2. And whatever I do on the denominator, I have to do to the numerator. 1 times 2 is 2. Now that we're looking at the same pieces of cake, denominator stays the same, and I simply add the numerators. 5 plus 2 is 7. Seems pretty easy. What happens if I have a number that looks like this? In this case, the best thing to do is to change your mixed number into an improper fraction. You do that by multiplying the whole number times the denominator. So 4 times 2 gives us 8. And then add the numerator. 4 times 2 is 8. Plus 1 gives us 9. 9 is my numerator, and we keep the denominator the same. Now I'm looking at similar types of fractions, but the cake is still not satisfactory. So let's once again find our multiples of 2 and 3. 2, 4, 6, 8, 10. 3, 6, 9, 12. Looks like we found something. It's going to be 6. My goal is to get 6 in both of the denominators. 2 times what gives me 6? That would be a 3. Whatever I do to the denominator, I must do to the numerator. 9 times 3 is 27. And on the other side, 3 times 2 gives me 6. 2 times 2 gives me 4. Now that I have the denominators the same, go ahead and keep that, and I add the numerators. 27 plus 4 is going to be 31. Now I know in previous grades you've always been instructed to turn your improper fraction back into a mixed number. I'm going to ask in 7th grade if you can please not do that unless you are specifically asked. I can't tell you why now, but you'll understand in a few weeks why I'm making that request. When you're subtracting fractions, you follow the same exact strategies. If you have like denominators, you simply keep the denominator and subtract the numerators. If you have unlike denominators, you find a common multiple, the least common multiple, and switch your fractions. Then you simply subtract. And if you have mixed numbers, you switch those to improper fractions and then take care of any issues with your denominator. Let me show you one example of each. If I have my first fraction, and we'll stick with like denominators here, 7/8 minus 5/8. My denominators are already the same, we'll keep that, and simply subtract my numerators. 7 minus 5 is 2. Ask yourself, can this be reduced? I do believe so. The greatest common factor of 2 and 8 is the number 2. I know that 2 can be divided by 2 for an answer of 1, and 8 can be divided by 2 for an answer of 4. My official documented answer is 1/4. If our denominators are different, let's go with 3/4 minus 1/3. This is where knowing your multiplication tables really helps. I know that 4 and 3, without having to list all of my multiples, have 12 as their least common multiple. So I'm going to try to get both denominators to 12. I know that 4 times 3 will give me 12. Whatever I do to the denominator, I must do to the numerator. 3 times 3 is 9. And I know that 3 times 4 will give me a denominator of 12. Again, repeating what I do on the denominator to the numerator. 1 times 4 is 4. Looks like we're dealing with some pretty good stuff, keeping the denominator at 12 and subtracting our numerators. 9 minus 4 is 5. And our last example for this video, let's take a look at a problem that is a mixed number. 2 2/3 minus 1 1/2. First thing we do is change these mixed numbers to improper fractions by multiplying the whole number times the denominator. 2 times 3 is 6, plus 2 is 8, and keep the denominator. 1 times 2 is 2, plus 1 is 3, keeping the denominator. We have a little bit of work to do. Knowing my multiplication tables, I know that the least common multiple for 3 and 2 is going to be 6. 3 times 2 will give me 6 in my denominator. Whatever I do on the denominator side, I must do to the numerator. 8 times 2 is 16. And I know that 2 times 3 will give me a denominator of 6. Repeating the denominator action to the numerator, 3 times 3 will give me 9. This is a subtraction problem, and we're now dealing with the same denominator, so we keep that the same and simply subtract our numerators. 16 minus 9 is 7. And if I ask myself, can this be reduced? I know that it can't. So my final answer would be 7/6. As with all of our learning videos, if you have any questions or concerns, just let me know and we can work through some problems together.